Hello, in this lecture we'll find out the area of a square. In the drawing we have a right triangle, triangle ABC is a right triangle. We know that side AB of the right triangle ABC equals to 5 units in its length, side BC equals to 12 units in its length. Inside this right triangle ABC we have square DEFG. And our mission is to find out the area of this square DEFG. So, first of all, we implement the Pythagoras theorem on the right triangle, triangle ABC. So here by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of the right triangle, triangle ABC is AC, therefore the square of the hypotenuse is AC square. So AC square must be equal to AB square plus BC square. Repeat again, in the right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. So AC square, that is the square of the hypotenuse, equals to AB square. AB is 5, therefore AB square is 5 squared, that is 25, plus BC square. BC is 12, therefore BC square is 12 squared, that is 144. So in conclusion, we found out that AC square equals to 25 plus 144. 25 plus 144 is 169. We take out of this equation and we get that AC equals to the square root of 169, that is 13. So AC, the length of the hypotenuse AC is 13. So write it down here. AC equals to 13 units in this length. In the next step, we define this angle that is actually angle ACB as alpha, and we'll focus on the right big triangle, triangle ABC. On the right big triangle, triangle ABC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. So the missing angle here equals to 90 degrees minus alpha. We define 90 degrees minus alpha as beta, that is to say 90 degrees minus alpha equals to beta according to our definition, and therefore the missing angle here equals to beta. Here 90 degrees minus alpha equals to beta, so if we add to this equation alpha and then we subtract beta, we get that 90 degrees minus beta equals to alpha. Okay. We have also the rule that the sum of the angles on one side of a straight line is equals to 180 degrees. Again, the sum of the angles on one side of a straight line is equals to 180 degrees. AC, the hypotenuse AC, is one side of the right triangle ABC, therefore it is absolutely a straight line. So if you focus on the lower side of the straight line AC at points D, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC 8.3, we have this angle that is a right angle, plus this missing angle. In total, they must be equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees in its size. Likewise, if you focus on the lower side of the straight line AC at point E, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point E? We have this angle that is 90 degrees plus the missing angle. In total, they must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees in its size. In the next step, we'll focus on this right triangle, triangle GEC. On the right triangle GEC, this angle equals to 90 degrees. This angle equals to alpha. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta. Therefore, the missing angle here equals to beta. The next step, we'll focus on the upper side of the straight line BC at point G. So, on the upper side of BC at point G, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So, which angles we have at the upper side of BC at point G? We have this angle that is beta plus 90 degrees plus the missing angle. In total, they must be equal to 180 degrees according to the rule that I mentioned, that the sum of the angles on one side of a straight line is equal to 180 degrees. So the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles. That is the sum of the angles on one side of a straight line. So the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Here, 90 degrees minus beta equals to alpha, therefore the missing angle here equals to alpha. In the next step, we focus on the small right triangle, triangle FBG. In the small right triangle FBG, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle here equals to beta. In the next step, we'll focus on the right triangle, triangle ADF. On the right triangle, triangle ADF, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle here equals to alpha. So in the drawing, we have in total 4 right triangles. 1, 2, 3, and the big right triangle, triangle ABC. In those all 4 right triangles, all the angles are equal to each other. Each triangle, the angles in each triangle is alpha, beta, and 90 degrees. Therefore, all the 4 right triangles are similar to each other according to angle similarity rule. And from the fact that all the right triangles are similar to each other, we can derive that a special relationship exists between their sides. For example, we know that the big right triangle ABC is similar to this small right triangle FBG, so I write it down. We know that the big right triangle ABC is similar to this small right triangle FBG according to angle similarity rule. Repeat again. The big right triangle ABC is similar, this is the sign of similar, to the right small triangle, triangle FBG. And from the fact that the big right triangle ABC is similar to the small right triangle FBG, we will derive that the following relationship exists between their sides. But before that, we'll define the length of side BG as x. So what is the length of GC? From the drawing, it is very easy to see that GC equals to BC minus BG. Again, BC minus BG equals to GC. So GC equals to BC, that is 12, minus BG, that is x. So in total, GC equals to 12 minus x. We will define the length of one side of this square DEFG as L. So EG equals to L. Therefore, all the other sides must be also equal to L because of the fact that all the sides of any square are equal to each other in their lengths. So DE is L, DF is L, and FG is also L. So, because of the fact that the big right triangle ABC is similar to the small right triangle FBG, we will derive that the following relationship exists between their sides. We will derive that BG over FG in the small right triangle FBG, BG over FG equals to BC over AC in the right triangle ABC. BC over AC in the right triangle ABC. Okay, repeat again. From the fact that the right big triangle ABC is similar to the right small triangle FBG, we derive that the following relationship exists between their sides. We derive that BG over FG in the right small triangle FBG is equals to BC over AC in the right big triangle ABC. Okay? So this is equation 1. So according to equation 1, BG over FG. BG is x and FG is L. So in total, BG over FG is x over L. And according to this equation 1, it is equals to BC over AC. Equals to BC over AC in the right big triangle ABC. So BC is 12 over AC. AC is 13. So in conclusion, found out that according to equation 1, x over L equals to 12 over 13. Here we will multiply this equation 1 by L, and we'll get that according to equation 1, x equals to 12 over 13 times L. Okay. Likewise, we know that the right big triangle ABC is similar to this right triangle EGC. Repeat again. We know that the right big triangle ABC is similar to the right triangle EGC according to angle similarity rule. And from the fact that the right big triangle ABC is similar to this right triangle EGC, we will derive that the following relationship exists between their sides. We will derive that side EG over side GC in the right triangle EGC is equal to side AB over side AC in the right triangle ABC. Repeat again. From the fact that the right big triangle ABC is similar to the right triangle EGC, we will derive that the following relationship exists between their sides. We will derive that side EG over side GC in the right triangle EGA in the right triangle EGC is equals to side AB over side AC in the right big triangle ABC. So this is equation 2. So EG over GC. EG is L over GC. GC is 12 minus X. So EG over GC, it is actually L over 12 minus X, and it is equals to AB over AC. AB is 5, and AC is the hypotenuse that is 13. So in conclusion, we found out that according to equation 2, L over 12 minus X equals to 5 over 13. Here we'll cross multiply this equation 2, and we get that according to equation 2, 13L equals to 5 times 12 minus X. Okay? So, we already found out that according to this equation 1, X equals to 12L over 13. So you can substitute X in this equation 2 by 12L over 13, according to equation number 1. And we'll get that according to equation 2, we'll do it now, we'll get that according to equation 2, 13L equals to 5. Inside the brackets we have 12 minus X. And X according to this equation 1 equals to 12L over 13. In conclusion, found out that according to equation 2, 13L equals to 5 times 12 minus 12L over 13. So 13L equals to 5. Inside the brackets we have 12 minus 12L over 13. Here we multiply 12 by 13 and then we divide it by 13 in order to have a common factor with this expression. So 12 times 13 is 156, so in total in the numerator we have 156 minus 12L divided by 13. So here we multiply this equation 2 by 13, and finally we get that 13L times 13 is 169L, and it is equals to 5 times 156 minus 12L. So here we open the brackets on this side of this equation 2, and we get that according to equation 2, 169L equals to 5 times 156 is 780, minus 5 times 12L is 5 times minus 12L is minus 16L. In conclusion, we found out that according to equation 2, 169L equals to 780 minus 16L. Here we'll add 60L to this equation, equation 2, and you get that according to equation 2, 169L plus 60L is 229L, and it is equals to 780. So here we divide this equation 2 by 229, and finally we get that L equals to 780 over 229. Repeat again. We actually found out that L, that is the length of one side of square DEFG, it is equals to 780 over 229. 780 over 229 is equals to 3.40611 units. So we know that the length of one side of square DEFG equals to 3.40611 units. The area of square DEFG is equals to the length of one side squared. The side squared. That is to say, it is equals to L squared. L is 3.40611, therefore L squared is 3.40611 squared. 3.40611 squared is 11.6016 square units. In conclusion, found out that the area of this square DEFG is equals actually to 11.6016 square units. So in the next step, I will summarize the lecture. So in this lecture, we found out the area of this square DEFG. So in the drawing, we have triangle ABC. Triangle ABC is a right triangle. Angle, that is to say, angle, this angle ABC equals to 90 degrees in its size. In addition, we know that side AB of the right triangle ABC equals to 5 units in its length. Side BC equals to 12 units in its length. Again, our mission is to find out the area of this square DEFG. So first of all, we implemented the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares from the perpendiculars. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC squared, and AC squared must be equal to AB squared plus BC squared. Okay, again, in the right triangle ABC, according to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. So AC squared, that is the square of the hypotenuse, equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. So in conclusion, we found out that AC squared equals to 25 plus 144. 25 plus 144 is 169, so AC squared equals to 169. We took a root out of this equation and finally found out that AC equals to the square root of 169, that is 13. So the length of the hypotenuse AC, this hypotenuse AC, is equals to 13 units. Okay? So in the next step, we focus on the right triangle ABC, and we define this angle that is actual angle ACB as alpha. So in the right triangle ABC, this angle equals to alpha. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in a triangle. So the missing angle here must be equal to 90 degrees minus alpha. But we defined 90 degrees minus alpha is beta, and therefore the missing angle here equals to beta. If 90 degrees minus alpha equals to beta, it means that 90 degrees minus beta equals to alpha. And we also have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. AC is the hypotenuse of the right triangle ABC, therefore it is absolutely a straight line. So if we focus on the lower side of the straight line AC at point D here, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle that is 90 degrees plus the missing angle. In total, it must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees in its side. Likewise, if we focus on the lower side of the straight line AC at point D here, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle that is 90 degrees plus the missing angle. In total, it must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees in its size. So in the right triangle EGC, this right triangle EGC, this angle equals to 90 degrees. This angle equals to alpha. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, according to our definition. Therefore, the missing angle here must be equal to beta. So we have here, if we focus on the upper side of the straight line BC at point G, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angle we have at the upper side of BC at point G? We have this angle that is beta, plus this angle that is a right angle, plus the missing angle here. In total, they must be equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles on the upper side of the straight line BC. So the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle here equals to alpha. In the right triangle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle here equals to beta. In the right triangle AFD, in this right triangle AFD, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle here equals to alpha. So in this drawing we have 4 right triangles, 1, 2, 3, and the big right triangle, triangle ABC. All those 4 right triangles are similar to each other according to angle, similarity rule. Why? Because each right triangle, each of those 4 right triangles, each right triangle consists of 3 angles, alpha, beta, and 90 degrees. That is to say, the angles of all triangles are equal to each other correspondingly, and therefore all the 4 right triangles are similar to each other according to angle, similarity rule. So, for example, the right big triangle ABC is similar to this small right triangle, triangle FBG. Repeat again. The right big triangle ABC is similar to the right small triangle, triangle EGC. And for that reason, the following relationship exists between the sides of those 2 similar triangles. Side BG over side FG in this right triangle, triangle FBG, must be equal to side BC over side AC in the right big triangle, triangle ABC. I repeat again. Side BG over side FG in the right small triangle FBG must be equal to side BC over side AC in the right big triangle, triangle ABC. Why? Because they are similar to each other. So BG is x according to our definition. Actually, if we define BG as x, then GC will be equal to 12 minus x. And if we define one side of this square as L, then all the other three sides must be also equal to L because of the fact that all the sides of any square are equal to each other. So BG, actually this is side BG equals to x and FG equals to L. So BG over FG is x over L, and it is equals to BC over AC. BC is 12 and AC is 13. So BC over BC over AC is 12 over 13. In conclusion, found out that according to equation 1, x over L equals to 12 over 13. Here we multiply this equation 1 by L, and finally found out that x equals to 12 over 13 times L. This is according to equation 1. Likewise, the right big triangle ABC is similar to this triangle EGC. Okay, because of the fact that the right triangle ABC is similar to the right triangle EGC, the following relationship exists between their sides. Side EG over side GC in the right triangle EGC is equals to side AB over side AC in the right triangle ABC. I repeat again. EG over GC in the right triangle EGC equals to AB over AC in the right triangle ABC. EG is L, and GC is 12 minus x. So EG over GC in total equals to L over 12 minus x, and it is equals to AB. AB is 5 and AC is 13. So in conclusion, found out that according to equation 2, L over 12 minus x equals to 5 over 13. Here we cross multiply this equation 2, and found out that according to this equation 2, 13L equals to 5 times 12 minus x. Again, 13L equals to 5 times 12 minus x. So we have x in this equation 2. We can substitute this x by the value of x in this equation 1. We did it and found out that according to equation 2, we have 13L that equals to 5. Inside the brackets we have 12 minus x, and x according to equation 1 is 12 over 13L. So we substitute x by 12 over 13L. Okay. So we have here 13L that equals to 5, and we have here 12 minus 12L over 13. You multiply 12 by 13 and then be divided by 13 in order to overcome factor with this expression. So 12 times 13 is 156. So in total, in the numerator of this expression, we will have 156 minus 12L divided by 13. Here we multiply this equation by 13 and found out that 13L times 13 is 169L. So 169L equals to 5 times 156 minus 12L. Here we open the brackets on this side of this equation 2, and found out actually that 169 equals to 5 times 156 is 780, and and 5 times minus 12L is minus 60L. So in conclusion, found out that according to equation 2, 169L equals to 780 minus 60L. Here we added 60L to this equation, equation 2, and found out actually that according to equation 2, 169L plus 60L equals to 229L. So 229L equals to 780 according to this equation, equation 2. Here we divided this equation, equation 2 by 229. And finally found out that L, that is the length of one side of this square DEFG, L equals to 780 over 229. 780 over 229 is 3.40611 units. So the length of one side of this square ABCD, the length L, is equal to 3.40611 units. And what is the area of any square? The area of any square is equal to the side squared, the length of one side squared. And we know that the length of one side of this square is L, therefore the side squared is L squared. And L equals to 3.4011, therefore L squared equals to 3.40611 square. And 3.40611 square equals to 11.6016 square units. In conclusion, found out the area of this square DEFG is equal to 11.6016 square units. Okay, thank you very much.